Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2183, refers to an issue with the Engine Coolant Temperature, ECT, Sensor 2 circuit indicating a range or performance problem. This error can arise when the readings from ECT Sensor 2 do not align with expected parameters, which can impact engine performance and fuel efficiency. The ECT sensors are responsible for relaying the coolant temperature to the Powertrain Control Module, PCM, to facilitate optimal fuel-air mixture and engine control adjustments. This particular code often indicates a malfunction or failure of ECT Sensor 2, located near the engine block in contact with the coolant. The sensor typically consists of a thermistor that changes resistance based on the temperature. Understanding and efficiently addressing this DTC is crucial to ensure your Honda CRV operates at peak efficiency and avoid potential overheating issues. Troubleshooting DTC P2183 should be performed carefully, and in some cases, it may also require checking for associated codes like P0111. DTC P2183 signifies a malfunction in the ECT Sensor 2 circuit, which is tasked with monitoring engine coolant temperature. This sensor is strategically located near the engine block, ensuring it accurately measures the temperature of the engine coolant, critical for managing engine warmth and performance. The readings from the ECT Sensor 2 are sent to the Powertrain Control Module, PCM, which uses this data to make real-time adjustments to fuel injection and ignition timing for optimized performance. If the readings from the sensor do not match predefined ranges, this leads to a performance problem that can cause the engine to run poorly or inefficiently. The impact is significant because the engine relies on accurate temperature readings for optimal operation. Addressing ECT sensor issues promptly helps prevent further complications, such as engine overheating. Several factors can lead to the triggering of DTC P2183. One primary cause is a faulty ECT Sensor 2, which may provide inaccurate readings due to internal damage. Another possibility is poor connections or wiring issues that can create interruptions in the signal being sent to the PCM. Corroded terminals or frayed wires can lead to inconsistent data, which in turn affects engine performance. Furthermore, defects in the Powertrain Control Module, PCM, itself can also be a contributing factor, impairing how the vehicle interprets sensor data. Lastly, any circuit failures between the ECT Sensor 2 and the PCM could hinder functionality, necessitating a thorough visual inspection of all related wiring and connectors. Addressing these potential causes quickly can avert more extensive repairs down the line. When DTC P2183 is present, drivers may experience several noticeable symptoms. An immediate indicator is typically the triggering of the check engine light, signaling the vehicle's diagnostic system has identified a problem. Additionally, poor engine performance may manifest as sluggish acceleration or irregular idling, as the engine struggles to adjust based on inaccurate temperature readings. Increased fuel consumption is also common, as the PCM attempts to compensate for perceived cooling issues, often leading to a drop in fuel economy. Overheating can occur if the ECT system fails to regulate cooling accurately, resulting in serious engine damage if left unchecked. Being attentive to these symptoms is crucial, as they can lead to progressive engine issues if not resolved in a timely manner. Drivers should address these signs seriously to maintain vehicle health. The first step in troubleshooting DTC P2183 involves a thorough visual inspection of the connectors related to the ECT sensors. The primary focus should be on ECT Sensor 1 and ECT Sensor 2 connections. as well as terminals that might exhibit signs of corrosion, loose connections, or damage. Such faults can significantly hinder the signals being sent to the Powertrain Control Module, PCM, resulting in incorrect readings. To perform this check, it is essential to switch the vehicle off, then access the sensors, which are typically found near the engine block. If any issues are detected during this inspection, repairing the connections or terminals must be prioritized before proceeding further with the diagnostic process. A clean and stable electrical connection is critical for sensors to function correctly, eliminating any variables that could lead to false DTC readings. After ensuring connections are secure, you can move on to the next steps in the troubleshooting process. In the second step, turn the vehicle to the on mode, which allows the vehicle electronics to power up without starting the engine. Utilizing the Honda Diagnostic System, HDS, will enable you to check for any pending or confirmed DTCs that are currently stored in the system. Identifying these DTCs is critical for assessing if other issues coincide with DTC P2183. If both DTC P011A and P2183 are indicated simultaneously, it means that ECT sensor 1 is also under scrutiny, suggesting that both sensors could be malfunctioning. In that case, you should proceed directly to the fifth troubleshooting step. If DTC P011A is not triggered, you will then move on to the third troubleshooting step, which focuses specifically on ECT Sensor 2's performance. Tracking these codes is essential in efficiently diagnosing the performance problem with the ECT sensors. At this step, it is crucial to start the engine and allow it to idle for approximately 10 minutes. This warm-up period enables the engine and its components, including the ECT sensors, to reach operational temperatures for accurate readings. Using the HDS, you will check ECT Sensor 2, specifically checking its signal values against predefined thresholds. The criteria for this check is that ECT Sensor 2 should read less than 120 degrees Fahrenheit or 49 degrees Celsius. If the current conditions match these thresholds, it indicates the sensor is functioning properly, and you would proceed to replace ECT Sensor 2 if it falls outside of this range. This performance check is pivotal, as it directly assesses whether ECT Sensor 2 operates correctly under typical operating conditions. Always ensure that your readings are precise, as they guide the necessary next steps. For this troubleshooting step, you will first need to turn the vehicle off and allow ECT Sensor 2 to cool down to ambient temperature. This cooling period is essential for accurate data collection, as it allows you to gather a baseline reading of the sensor against the current environmental temperature. After waiting for the sensor to cool, note the ambient temperature in degrees Fahrenheit or Celsius, which serves as your reference point. Next, turn the ignition back to on mode and quickly check the value of ECT Sensor 2 using the HDS. The goal is to determine whether this value deviates by more than 5.4 degrees Fahrenheit or 3 degrees Celsius from the recorded ambient temperature. If the sensor's value differs significantly, it indicates a clear fault, warranting sensor replacement. Conversely, if it falls within range, the error may be intermittent, requiring further inspection of connections or terminals associated with both ECT sensors before establishing whether a failure exists. This step requires that you start the engine again and let it idle for another 10 minutes, providing the necessary conditions for the ECT sensors to offer reliable temperature data. As with ECT Sensor 2, you will be using the HDS to check the performance of ECT Sensor 1. The crucial threshold to match here is also less than 120 degrees Fahrenheit or 49 degrees Celsius. If ECT Sensor 1 data meets this requirement, it indicates that this sensor is working well and does not need replacement. However, if it does not match, ECT Sensor 1 should be replaced. This troubleshooting step is similar to the previous one, but focuses on assessing the functionality of a different sensor, ensuring all related components are thoroughly evaluated for optimal performance. As such, proper interpretation of these values is critical for diagnosing any ongoing issues. For step 6, you will again let the engine idle for approximately 10 minutes. During this time, the engine coolant should stabilize, allowing accurate data collection for ECT Sensor 2. As before, assess the parameter values using the HDS, aiming to see if the current values are less than 120 degrees Fahrenheit or 49 degrees Celsius. If the values are consistent with this criterion, it confirms that ECT Sensor 2 is functioning properly and does not require any replacement. Conversely, if the current conditions readings fall outside this threshold range, replacement of ECT Sensor 2 is warranted. This step further confirms whether the sensor in question is properly relaying temperature data to the PCM. A thorough approach in evaluating these readings ensures accurate diagnosis and helps prevent unnecessary replacement of parts that may still be functional. In this final troubleshooting step, start by turning the vehicle to the off position and allow both ECT sensors to cool to ambient temperature again. Like previous checks, it's crucial to document the current ambient temperature accurately, as it serves as a benchmark for evaluating the sensor's operation. Once the sensors have cooled, switch the vehicle to the on mode and quickly check the values of both ECT Sensor 1 and ECT Sensor 2 using the HDS. You are looking to determine if either sensor deviates by more than 5.4 degrees Fahrenheit, 3 degrees Celsius from the ambient temperature. If one or both sensors show a significant difference, the respective failed sensor will need to be replaced. If they show consistent values within the acceptable range, it suggests that the system is currently functioning well, but it may require further inspection for loose connections or intermittent failures. Having a holistic viewpoint on the values here is essential to ascertain the integrity of the entire ECT system. Once the necessary repairs have been performed, it is important to conduct a final verification to ensure the issue has been resolved effectively. Start by checking for any remaining DTCs using the Honda Diagnostic System, HDS, to confirm that DTC P2183 has cleared from the system. Following this, a test ride should be conducted to assess whether the vehicle operates as expected under normal driving conditions. During the test drive, pay attention to engine performance, checking for smooth acceleration and the absence of any warning lights on the dashboard. If the vehicle performs well and remains free of error codes, the repairs can be considered successful. This final verification step reinforces the importance of thorough diagnostics and proper repair implementation to ensure the vehicle is in the best working order. To avoid encountering DTC P2183 in the future, implementing preventive maintenance practices is essential. Regular inspections of the connectors related to ECT sensors should be conducted, ensuring they are clean and free from corrosion. Cleaning terminals regularly preserves their conductivity and helps maintain a stable electrical connection. Additionally, having a routine check of the coolant system ensures that it's functioning efficiently and that no leaks or overheating issues arise. Furthermore, being proactive in monitoring the overall performance of ECT sensors and associated components significantly reduces the risks of sudden sensor failures. These practices contribute to the longevity of the vehicle's systems and enhance overall engine reliability and performance. Ensuring everything is in top shape can save on costly repairs and keep the vehicle operating smoothly. In summary, DTC P2183 points to malfunctioning conditions within the ECT Sensor 2 circuit, which can lead to significant engine performance issues. Precise diagnosis through each troubleshooting step is essential for identifying the root cause effectively. It is crucial to monitor ECT sensor readings consistently and ensure that all electrical and connector aspects are sound for reliable sensor functionality. Any issues that arise should be addressed immediately to prevent further complications and more significant repairs down the line. Implementing preventive maintenance practices is vital for upholding the integrity of your Honda CR-V's cooling system. By being diligent with inspections and repairs as needed, you can ensure the longevity and efficiency of your vehicle, leading to a better overall driving experience. Please like and subscribe to the channel. See you next time.